Dear civil engineers, this is Engineer Hedaetullah from School of Civil Engineering. In this lecture, I'm just going to show you that how we'll design our Shear by using three methods that are available in Etabs. Okay, so one by one, I will discuss about all of that method and I'll show you that how we'll perfectly utilize that method to design our Shear. So let's start. And before starting, if you're new to our channel, then don't forget to subscribe to our channel and also press the bell icon so that you get every update above first. Now I'll just select all of our Shear, okay, and I'll right click show selected object only. Now you're seeing here our Shear is here. Now which portion of our all you want to design, you have to select that. So I'm just rotating it, and suppose I'll design that section, okay, I mean that side. From here I'll click here all story, I'll click any of it, and again I'll right click and show selected object only. Now you can see here only that one part of our Shear is available. Also I can hide our grid for perfect visualization. Okay, now I'll just select them and I'll go here for assign, then shell, and after that wall auto mesh option. So by using that option I can use that default option, otherwise I can go auto rectangular mesh, and if I use that option, so it will create mesh on every 2 feet, so I can consider for 1 feet. Then I'll click OK, then apply, then OK. So our mesh option also done. After that we have to select, and before design we have to assign our pier level. So I'll just select, and after that I'll go assign, then shell, then here if we just go down pier level, and from here I'll select that pier level P1, or you can create another from here, define, then pier level, and you can add name, different name as per your requirement actually. So I'll select pier level 1 for that wall, and I'll click apply, and then OK. So we have defined our pier level. So when it's done, now we'll go for analysis. I'll just analyze that. Okay, so our analysis is done and it's refreshing our windows. So you can see here is the maximum displacement for our dead load, and previously we have checked our model, okay, that our model is okay or not for displacement limit. Now I'll just click here for undeformed shape, and after that I'll just select all of them, and I'll go here in that option Shear design, or here in design option, then here Shear design. Clear? After that we have to go assign pier section. Okay, assign pier section, and after that they have 3 methods. So first of all I'll show you about that method, simplified C and T design. I'll just click on it. Okay, after that when this okay, after that I'll just go again from here or here I can go, I'll just go here, and from there I'll just go here Revest Overrides. I'll click here and we'll check that our method is okay or not. So pier section type simplified tension and compression method design, and design is seismic. You have to select yes or no, so we'll design for seismic load. And after that materials, you have to select the materials, which material you are using, and also the thickness bottom, then here also top thickness and bottom length of bottom and top length. And if you need that boundary element value, if your value is pre-calculated, then you can add here, otherwise no need. Okay, so I'll leave it default. I'll click here OK. It's done. When it's done, now I'll click here and I'll go start design check. So I'll click here and see what happened. So if I zoom that, okay, so if I zoom that and if I go for top, now we are seeing that for a left side and right side value, if I just right click here, we will get a detailed design value. And for left top and right top, here we are seeing that our river area, and here also left bottom and right bottom, here is our river area. Clear? And here its length 10 inch, its length 10 inch. Okay, so here for flexible design we get our, actually this is for flexible design tension reinforcement, this is for tension reinforcement, and flexible design for compression reinforcement. And on the top level we required, okay, left top and right top we required reinforcement for our compression value. And here the boundary element check, okay, boundary element check, you are seeing that for our top left and top right and bottom right we required its length for boundary element for 5 inch, 5 inch and 5 inch, and but for bottom left no required for that value. Okay, and here C value of C depth in 10 inch, 10 inch and 10 inch. Clear? And C limit in here, so you can see that the critical depth and limit also, right? I'll just close it, and if you just go top, and here if I right click here, okay, so for that portion no requirement for tension and reinforcement, okay, also. So I'll just close it, but overall, in overall distance we will provide the maximum reinforcement where we are providing. Clear? So after that, when it's done, I'll click here show undeformed shape, and as it is selected, I'll show you about now our next design method, uniform reinforcing method. So to use that method, again I'll just go here, and from here I'll go assign per section, and from here I'll select uniform reinforcing. I'll click here, and you can see that here is our reinforcement. We will use our this materials property, then bar size I will use 60 mm bar, then spacing I will use 10 inch spacing for our distributed bar, and here for cover rebar I will use 1.5 inch, and here its corner bar I will use 20 mm bar, no problem. And obviously I'll first of all I'll click here reinforcement to be checked, I'll click OK. After that, again I'll select all of our that section, and I'll go here view or Revest Override. So we can see here our uniform reinforcement here, and our its bar number, our another bar number, that value, everything is available, we have defined here. And reinforcement check or design reinforcement, it should be check. I'll click OK. After that I'll click here for start designing. Okay, so I'll just click here. Now we can see that here our available reinforcement is here. Everywhere it's just reinforcement we have provided. I'll just skip. Everywhere reinforcement we have provided that are 4.4417, and I'll just go here display design info. I'll just pyre reinforcement ratio apply, and here I'll just go pyre DC ratio. Okay, so DC ratio, here we are seeing that our DC ratio, and also I'll identify all failure. I'll click apply, so no failure is available. Okay, our structure is okay, and pyre its boundary zone with apply. So we can see that for our top river not required, but for our bottom, that for our bottom, that 2 section here, we've seen that this is required. Okay, so this is our, if we right click here, we can see on its length. Okay, our boundary, its length, we required 12.58, and for bottom we required 15.38. Clear? So I'll just, and we can see here critical depth C, value of C here for top 17.58, and for bottom 20.38, and the limit 11 point. This is the limit actually, and this is the critical depth length. I'll create another video on it. So I'll just close it, and from here the pyre longitudinal reinforcement. Okay, then okay, the value we have provided here. Okay, these are provided value. Now what we'll do actually, I'll again select, I'll go here for shear all design, I'll go assign pyre section uniform reinforcing, and I'll select reinforcement to be designed. Okay, then I'll click OK. After that I'll go here and I'll click here, I'll again select them, and again I'll click here for view or revest pyre override. So we can see here it should be designed. Okay, then okay. After that again I'll go for check design. Now we can see here we have provided the reinforcement more than 4, but we are seeing that for our bottom we require reinforcement for 1.25 inch only, for our top 1.25, and for that section 3.9, and for bottom 1.7, here 4.17, here 3.47. actually this the reinforcement actually required. Okay, so if I right click here, now we can see that our provided reinforcement is here for top and bottom, and required reinforcement ratio. Okay, so here is our required reinforcement ratio, and our current reinforcement ratio is here. Clear? And for shear also 0.03, 0.03 for leg 1, and for that section we need boundary element. Okay, 10 feet 9 inch, 10.9 inch, 19 inch, 12.39 inch, and 12.39 inch, and this is our critical depth in inch 15.19, so we can consider 15.25, and here 17.5 we can consider, and this is the limit of critical value 11.1. Okay, so in this way also we can design our that part section. After that, okay, so after that what we'll do, again I'll select them, and after selecting I'll just click here. Okay, and I'll click here for our general reinforcing. Actually before, so I'll click general reinforcing, and before using the general reinforcing I have to assign section. Okay, so to use that general reinforcing section we have to go here, sorry, we have to go define general pyre section. I'll click here and add pyre section, and from here our pyre 1, I'll provide its name pyre 1, and this is our materials, and from here add pyre from where. Okay, so I will add pyre from our, for which story actually I will assign pyre. Okay, so you have to select that. Okay, start from existing wall pyre, start from existing wall pyre. Okay, so here our pyre 1, and I'll just click actually for, if I consider for story 1. Okay, and we have to click here modify or show section designer. So I'll click here. After that, we're seeing that there are some reinforcement available. So what I can do, that I can right click here to change it and clear cover 1.5. I can change the bar size, so I'll use bar size 16 and I'll provide the max bar spacing, that is 8 inch, and number of bar. Okay, so no need to use that option, number of bar. Clear. So we'll use our bar spacing 8. So if I just click here, apply to all its, then okay, just see here this is available. Again, if you need to change it, you can also change it from here. Clear. So I'll just click OK. Also from here you can see interaction surface by clicking here. Just see, here is our interaction surface. So I'll close it. Now when it's okay, I'll click OK, and here this is a pair section study 1. So I'll click OK. So here we're seeing that pair 1. Now I'll click OK. Okay, so after that I'll just go here and I'll go assign per section and general reinforcing, and from here I'll select that option. Okay, I'll select that option. I mean from here, for section at bottom pair on, section at top pair on, and they have two options, check or design. Okay, so for check or design, we can select our reinforcement to be checked or reinforcement to be designed. We have two options, okay, to work here. Now the question is, for which option will work? Okay, now first of all I'll select our that option, reinforcement to be checked. What we have provided, that should be checked. Then I'll click OK, and after that I'll just go here, view or overwrite, and from here, okay, it's okay, general reinforcing option that's have been selected automatically, pair 1 for pair on check, no, then okay. And after that I'll go here and I'll click start design check. Now you can see here, this is our reinforcement, our provided reinforcement for our pair section. Okay, for our pair section, what we have provided for our model. And if I right click, I mean click here, and if we select and if we show identify failure, apply, so no issue with our model. Again I'll click OK. I'll just go here, I'll go, that should be okay, and general reinforcing option, I'll select them both and reinforcement to be designed, then okay. Then again I'll go here, and from here I'll go view override, and it should be designed, okay, check and general reinforcing, then okay. After that I'll go start design or check and see what happened. And also we are seeing that our general record reinforcement 1.47 here, so everywhere we are seeing that. Is it clear? So this is the way. And also after getting that value, okay, after getting that value, if you need to design that, then I have some Excel. If you need that, you have to join as a member. Okay, so if I just click here or revert detailing, this all are created as per ACI. So I'll click here, share all river and design. Now in which method we want to work, so I will use in FPS method, and the height of all. So for one all, I'll select height of all 10 feet, and length of all, what should be the length of all? I'll come here and suppose I will design for that all. Okay, so I'll right click and our length 15 inch. So 15 divided by 12. 15 divided by 12. So length is, I'll just copy from here, 4.166 feet. And what is our wall thickness? So that should be 10. Also, if you need to work in MKS, then you can select from here. So I'll work with FPS. After that, our vertical reinforcement. What is our vertical reinforcement? I'll just go Etabs, and here we are seeing that our for top reinforcement, that is 3.33 for bottom. So I will use 4.34 inch overall everywhere. So I'll just go, I'll provide here 4.31. okay, what is that actually? 4.3413. okay, 3413. And number of bar I'll use, that is how much? 16 mm. And from here, minimum required river ratio, from here, I mean from our document, we'll get that this is the required reinforcement 0.0073 for bottom. So I'll use that 73. okay, so here we are actually required spacing, that is 7.81. now we have to provide a spacing for I'll provide for 7 inch. okay, so we are providing reinforcement for 7 inch, and our allowable maximum spacing 16.67 inch. okay, so I hope this is okay, and our that provided river ratio, that is also okay. Now we'll go for horizontal river. So here I'll go here, and what is the value? 0.3. Our horizontal river is 0.3. so this is 0.3 inch per feet. So here 0.3, and I'll use our that vertical, sorry, I'll just change it. I've done a mistake here, little mistake. okay, so it's done. And here our required spacing is 9.74, but here I will use 9.5, and our allowable is 10. Our allowed maximum spacing, that is 10 inch. So this is the way. okay, so this is the way to design our shear, and here you can see the spacing and as per ACI code here, and also for boundary element or for a special case you can read here if you need. So I hope this is clear to you, and I hope now you'll be able to design a shear by using any method that are available in Etabs. So thank you very much. And also, if you want to support our channel, then please join as a member in our channel. The join option are available beside our subscription button, and don't forget to also subscribe us. So thank you very much.